Hey guys, welcome to our channel. This is Science Lectures 256. Thanks for being with us. Thank you for subscribing. Continue subscribing. We really appreciate the initiative. It really means a lot to us. And we are still continuing with our biostatistics lectures. And today we are going to look at a measure of central tendency called mean. Remember, we defined earlier on in the video which I first posted, and we had talked about what mean is. And we had talked about the measures of central tendency as a main division of descriptive statistics. So today we are going to dive into the details of what really mean is. So mean, to start off with mean, you remember we had another name we had given mean. Mean can also be called the average, the mean or average. That middle number of our data set, that number that represents our data as the average value. So mean is also known as the average, but this mean can be divided into two. We can have a population mean of the population, the entire population, and mean of a sample, which is also called the sample mean. So mean of the population is denoted by mu, which is written as u like that. Then we can also write it as mu. Then a sample mean is denoted by x bar, and x then we put a bar. That is the sample mean. So mean of the population is denoted by mu, and the sample mean is denoted by the x bar. So that is briefly an introduction about the mean, but you need to know basic things about this mean is that if we are having mean of a large population, normal distribution, if we have a large population, in statistics, what do we mean by a large population? A large population is a population where we have n greater than 30. So whenever we have n greater than 30, it's a large population. And such a large population will go for a test referred to as a parametric test. Parametric test. Like we are going to see further how we are going to apply the term of parametric and non-parametric tests. But currently we need to know that for a large population of n greater than 30, where we have normal distribution, we'll use a parametric test for our mean. So in this case, mean might be the parametric test we are going to use for a large population where we have normal distribution. Large population is of n greater than 30. So this is something we need to note before we go further. Then mean can either be representative or non-representative. For this we need to know. Mean can be representative in some cases, or it can be non-representative. And before we go further with mean, we need to know that mean is the commonly used measure of central tendency. So this is the commonest measure of central tendency used. Mean is the commonest measure of central tendency that is used. So mean can either be representative or non-representative. When does mean appear to be non-representative? If we have a population or a data set where we have very low or very high values, very low or very high values will give us a mean that is non-representative, like we are going to see in our discussion of how mean is representative and how mean is non-representative. So for our calculations, we are going to calculate example 1, the mean for example 1 and the mean for example 2, and it will further help us explain how mean can be representative and mean can be non-representative. So we are going to use our scientific calculators to calculate the mean, and I will take you through the process of how to use a calculator to calculate this mean, and you will get the answers of how the mean is calculated. So we are going to use these calculators to obtain the mean, and I will later on upload a video that specifically will guide you, on how to calculate this mean. But for today, I'm going to calculate it very fast, then give you the answers for the mean of, but you can as well be calculating to see whether whatever I've gotten is right. If your answers are not matching mine, you can comment in the comment section. So for example one, the mean of this sample, which is x bar, the mean of the sample, x bar, I'm getting, according to my calculation, I'm getting 4.81818. That is the mean. Then for example 2, I'm getting a sample mean x bar of 10. So these are the two means I'm getting for the two examples. Example 1 is 4.81818, and example 2, the mean is 10. But if you're to remember how we're defining mean is the average. That means it does that number that will specify that central position. And if you're to be so keen, for example 1, you're seeing we are getting 4.818. It falls around the region of, because the lowest number in example 1 is 2, and the highest number is 8. So at least this mean is, at least it's a reasonable mean if we are to guess. Then, for example 2, we are seeing that along all this data set, we have an 8 somewhere there, but we have a mean of 10, and we have a value which is 60. So in this case, if we are to say that the mean of example 2, the mean is 10, this mean is not representative of the data set, because it is leaving very many values behind the data set and one value above the data set. So this mean looks to be not representative. Why? We said non-representativeness of the mean is as a result of very low or very high values within a given data set. So an imbalance within the data set values causes the mean not to be representative. So what is the solution for this? In this case, we'll have to use the median as a measure of central tendency. So wherever mean fails to be used as a measure of central tendency, we use the median. Like we are going to define later on difference between parametric and non-parametric tests. Parametric tests will utilize mean as a measure of central tendency, and non-parametric tests will utilize the median as a measure of central tendency, because we've seen mean can fail to be representative of our data set, like in example 1. And as well, if it fails, we can use the median. So in this data set, we'll simply just use the median by cancelling this value and that value, then this value with this value, then the value here with that value, the value there with this one with this, and our median will happen to be a 7. So we'll take the median instead of the mean, because the mean is not representative. This is very important when we are dealing with calculations. Mean, median, and mode as measures of central tendency, but we also had something called the measures of variation. And in the measures of variation, if you didn't watch that video, you please revisit that video. The measures of variation, we had a standard deviation, standard error, and variance. So I will be talking about the standard deviation and the variance. In this video, we are also going to introduce standard deviation and variance. So, standard deviation. What is standard deviation? What is SD? What is this standard deviation? So standard deviation is how data are spread from the mean, or we can say how far data are spread from the mean. So this is how data are spread from the mean. So for mean, we said we have two means. We said we have a population mean and a sample mean. And we said the population mean is denoted by mu, and the sample mean is denoted by x bar. So let's use mu. Let's imagine we are using mu. So if this is our data, and this is mu the mean, and here we are having our other data. Let's say mu plus y, mu plus 2y, Then here we are having mu minus y, mu minus, so this is mu, and this mu is the mean. Let's imagine this is our mean, mu. Now these are other data, this side and this side. So how the data are spread from the mean is what we refer to as standard deviation. So standard deviation is how your data are spread from the mean. The mean is mu in this case. The mu plus y is the first standard deviation. Second standard deviation is mu plus 2y. So that is simply standard deviation, how your data spread from the mean. But as well, standard deviation has also a population standard deviation and a sample standard deviation. So for the population standard deviation, we denote it by sigma. So sigma is the population standard deviation, and the one for the sample is denoted by small s, just simple small s. That is the whole issue of standard deviation. So still we are going to use our calculators using these two examples we used earlier on to calculate the mean. We are going to use them to find the standard deviation. So the calculators, I will upload a video and show you how to really use these calculators to obtain the mean and the standard deviation as well. But if we are to calculate for the first one, for the first example, we'll get a standard deviation. I expect you guys to get a standard deviation of 1.712, but we can round it down to 1.7. We can use that. Then for the standard deviation of example 2, where we had a mean of 10, I expect you guys also to have something like 16.69 as the standard deviation. So we'll be using our scientific calculators to get the mean and the standard deviation. But the standard deviation tries to show you how the data are spread from the mean. So there is another concept we also need to look at and to cover, something called variance. And it has a very close relationship with the standard deviation. So variance by definition is used to assess, the variance is used to assess normality. It assesses normality between the data sets, between two data sets. So it will assess the normality between two data sets. But how do we get the variance? The variance is obtained by squaring the standard deviation. So variance will be equivalent to standard deviation squared. But that means to get the standard deviation, we get the square root. Standard deviation is equivalent to square root of the variance. And these are very important, as we are going to see in our further discussions when we are talking about the different tests, like the t-test and the z-test. We'll be using these concepts largely. So for the variance, we square the standard deviation. For the standard deviation, you get the square root of the variance. One more last concept that is left for us to have to round up all this, something called CV, not curriculum vitae, but coefficient of variation. Something called CV is what we are going to look at. CV, or we can say coefficient of variation. Coefficient of variation, or what we refer to as the CV. So the CV will be used to compare. It is going to be used to compare the means, the populations with different means. So how do we calculate the CV? That is the most important thing. CV is calculated by getting the standard deviation over the mean, but it is always expressed as a percentage. That means times 100. So the coefficient of variation, that is how it is obtained. Standard deviation over the mean times the 100. So we are going to use the same, we can use the same examples to calculate the CV for each. So for example 1, we'll get the standard deviation, which is 1.7. We divide it with the mean, which is 4.8. We multiply by 100 and we'll obtain a value for CV. Then the same applies to example 2. We'll get the standard deviation, which is 16.69, divided by the mean, which is 10, times 100, and we'll calculate the CV for each. So if we are to calculate, we'll say this is 1.7 divided by 4.8, then times 100. I'm getting a CV of about 35.4, of about 35.4. This is expressed in terms of 100. This is a percentage. Then we can have also this one calculated, 16.69 divided by 10 times 100. Wow, this is giving me a value which is way higher. That is 166.9%, and this is the value it is giving. So these values of the coefficient of variation also speak something to how the data is, to the type of data we are having. The CV for example 1 is 35.4%, but the CV for example 2 is 166.9%. Because the data were not normal, you see, the data had what we call an outlier. It had a 60. That is why our CV is turning out to appear like this. And as well, you realize that the standard deviation is way above the mean in example 2. So that is the difference in the data, and you have to be keen with your data to see whether there are any outliers, because they might shift the way your results appear to be. So that is it for this video, please. Thank you.